All right, does somebody want to take a moment and look back at your notes and summarize what is the intermediate value theorem? Can someone, in their own words, describe what the intermediate value theorem was? Let's see if I can pick somebody to do this. Maria Flores, can you please tell us, in your words, what is the intermediate value theorem? Look back at the notes we took last time. What is the intermediate value theorem? Continuous on a certain intervals. Continuous. Oh God, why is this not working? Yes, f of x must be continuous on an interval. What else? What does that mean? Yep, that's number 2. Y value. Y value must be the Y value that we're looking for, right? The Y value we want to find must be between f of A and f of B. What else? X value has to be in a point spot. What does that mean? Yes, that's it. That's the third part, exactly. There must be an x value. That's the third part. That's what we're trying to show. There must be an x value. We call it C, where I should say. Hold on, I need to add something here. There must be an x value C that is between A and B, where f of C is equal to, well, y value, we're going to call this y value k, right? Is k. It's equal to that y value. Exactly. Thank you, Maria. Great. Right, so that's the intermediate value theorem. In a nutshell, that's what it's talking about. We're looking at a function. F of x must be continuous on an interval from A to B. Right, these three criteria for the intermediate value theorem. F of x must be continuous on the interval. We're testing. The intermediate value theorem is like a test. We're testing for some y value that's we call k. It has to be between the y values of the function we're looking for, between the low and the high, right? Must be between f of A and f of B. And there must be an x value. If this y value is between A to B, somewhere in the interval, there's an x value, we call it C, somewhere between the A and the B, where if you plug that x value in, you will get that k value that we are looking for. So these three criteria are what the intermediate value theorem is saying. F of x must be continuous on some interval. If it's continuous, then we test this y value. If we're looking for a y value that's between A to B, there must be an x value between A to B where some that x value, that c value, if you plug that x value into the function, you will get that k value. And it's the intermediate value theorem. It's basically saying that it touches all the points. Right? The intermediate value theorem, it's intermediate. It's in between. Everything, if everything is in between this section, right, that's the intermediate value theorem. Intermediate value, a between value. That's the definition of the intermediate value theorem. So these three criteria must be met, and we can use this intermediate value theorem in lots of kind of interesting ways. We can do lots of interesting proofs, right? We mentioned last time, for example, say that you have a table of x and f of x, and I say things like x is, let's say, -5, 2, and 20. -5, 2, and 4. And I've got my x value of 3, 9, and 6. And I can ask you, does f of x equal 7 on the interval from -5 to 4? Do we know, can we show, does the function touch the number 7 somewhere on the interval -5 to 4? These are the kinds of questions you get whenever you're looking for a value on an interval. Intermediate value. Interval, value, intermediate value. Interval, value, intermediate value. Interval, value, intermediate value. I'm going to say it again because when you're taking your test, you want to be able to recognize these questions. You look at this question, you say, what does this question want me to do? How do I solve this question? What does it want me to do? It's looking for a value. It's looking for a value on an interval. That's the intermediate value. That's how you'll recognize these questions on the AP exam. It's looking for a value on an interval. Does this interval, does this value, does f of x reach this value on this interval? And you can, we can take a look, right? You can imagine, right? You have to imagine in your mind this -5, 2, and 4. You can picture this graph. You can look at this graph and think, okay, if I'm at 5, I'm at 3. Here I am at 3. 2 goes up to 9, right here, and 4 goes to 6 right here. So you can imagine this picture of the graph. You know it starts at 3, it's got to somehow go up to 9 and then back down to 6. So looking at this, does it touch 7, everybody? Does it touch this value of 7 right here? Here's 7. Are we going to reach 7 somewhere on the graph? Yeah, right? Clearly, it's got to go up past 7 to 9. It's got to go back down from 7 to 6. And we could say yes, because f of x is continuous. I guess I should have stated that. I didn't state that, everybody. That was my bad. I should have said, does a continuous function f of x, I have to let you know that f is continuous. Does a continuous function f of x, I just abbreviate continuous, continuous function f of x on the interval, blah, blah, equals 7. So we would say yes, because f is continuous on the interval, -5 to 4. Or we can even, well, yeah, we would say continuous on the interval -5 to 4. -5 to 4. And, right, we have 3 parts. These intermediate value theorem questions require 3 steps. State that it's continuous on your interval. And state that 7 is between 3 and 9. Ooh, here's a problem. 3 and 6? We go from 3 to 6. So would I use 4 and 6, right? Because this has to be f of a. This has to be f of b. And f of a. Oh, and this is, sorry, this is just a. And that's b. So do I really want to use all the values here, a to b? Do I really want to use this is my a and this is my b? Is that going to help me prove it? Because if it's 3 to 6, 7 is above that. I can't use the 6. Right? I want to use the 2 values that are between my section. So I would not use this 6, not use the 4. I would say -5 to 2 and 3 to 9. I can choose the limits that I want to do. And it's okay to reduce it, right? I can choose from -5 to 2 because -5 to 2 is still within this interval. -5 to 2 is still within the interval from -5 to 4. We're using a smaller section. It's okay to use a smaller section. I cannot get bigger. I can't use a bigger section. I can't say, well, over a 10, it gets much bigger. I have to use a small section, somewhere in this range. I can use a smaller section of the range. I can say, well, 4 is not helpful, but 2 is helpful. So I'm going to go from -5 to 2. So you can choose a smaller part. How am I going to put this? Can choose a smaller interval. Don't want to go here. I want to go to here. So you pick the interval that makes what you want to show true. I got to use from 3 to 9. So part 1, I say that f is continuous on that interval -5 to 2. And I know it's continuous on this smaller interval because it's continuous on the bigger one. So I shrank my interval, that's okay. Right? And 7 is between f of a and f of b, 3 to 9. That's part 2, right? I need these 2 pieces, continuous and between. And so I say, so there exists an x, or I could say a c between -5 and 2, where f of c is equal to 7. Part 3. That's how the intermediate value theorem works. If you're looking for a value on an interval, You need to declare that it's continuous. These three pieces. You need to declare it's continuous. You need to declare that your point is between the low and the high, the y values. Use the y values. And then you need to state that, yes, there is a point between -5 to 2 where f of c is 7. Or f of c is whatever, right? Those are the kind of questions, right? Here's another question for you. Same graph, same equation, right? Is there a place where the graph f of x equals, let's say, 10? Does the function ever reach the number 10? Producer says no. Are we sure? What if my graph looked like this, Perry? So what if I went like this? Woo, up like this. What if my graph did this? Is my graph allowed to do that? Yeah. My graph could look like anything, right? Or what if I say, what about does f of x ever equal 0? Maybe it does. Maybe my graph goes down like this, and then back up, and then like this, right? Yeah, it's possible for sure. It's definitely possible. Can we prove it? Can we prove that it is? So the answer to these questions, yeah, is maybe. And we don't like maybe in math. Yeah, we say we can't know, right? We cannot show for sure, right? We don't know for certain. We do not know for sure. It's definitely possible that the graph could look all kinds of ways, but we do not know for sure. Exactly. We would say there's not enough information, Lizette. We not only not enough information, we would say that the value is outside the range, right? F of f of x equals 10 is not within 3 to 9. So we don't know. It's definitely possible the graph can do all kinds of different weird things, but we cannot say for sure. And if we're not sure in math, if we are not certain, we cannot say anything about it. So we would not be sure. And so we would say unknown or we can't tell, something like that. We cannot say because something like that. Because 10 is not within the boundaries of f of a to f of b. Something like that. Oh gosh. Because f of 10 is not within, that's w with / in. Maybe I should just write it out. Within the boundaries of f of a and f of b. Yeah, there's not enough information. We can't say for sure. Great. So what other situations arise? What about something like, what's something like this? Let me think. Questions that you'll have. Okay, sometimes you're asked the following things. Maybe let's say I want you to say for f of x is equal to a function. Let me give you an equation. Let's say x squared plus 3x minus 1. Right? And I want to say prove that f of x equals, let's say, what's a good one? Let's see. Hold on, everyone. Let me just do some quick calculations. Let's say 5. Prove that if x equals 5 on the interval 0 to, let's say, 4. So I want you to show me that this equation has some value, right? That this equation touches 5 somewhere on this interval. What do we need to check? We need to check 3 things. Check 3 things. 1, is it continuous? Oh goodness gracious. Continuous. Is it continuous on the interval? Continuous on interval. Check. My God, what is this even doing? Check 3 things. 1, is it continuous? What do we think, everyone? Continuous on the interval? Is this function continuous? How do we know about continuity? Remember, there's 3 types of breaks, 3 types of discontinuities, about 4, but really, we have to check for discontinuities. Does it have an infinite discontinuity somewhere? Do we have an asymptote in this equation? Any asymptotes in this x squared equation? No, right? It's a parabola. We're not dividing by. It's not a rational equation. We're not dividing by anything. Only when we divide do we have asymptotes. So no asymptotes. Good. Any holes in this equation? Same thing. Any holes? Probably not. Right? It's a parabola. It's a regular parabola. We're not dividing by anything. Holes and asymptotes come from the denominators. Are there any breaks or jumps? Right? It's not a piecewise function. Nothing crazy going on. So no breaks, no holes, no jumps, no discontinuities in this equation. In fact, it's a regular parabola. You should be able to, over time, you'll get familiar with these intervals, with what kinds of equations have discontinuities, what types of equations to look out for. Parabolas are fine. Any polynomial, in fact, if there's not a division on the bottom, if there's no rational equation, if there's no fraction, any polynomial is going to be fine. So this is a continuous? Yes. No problem. Continuous on the interval? Yes. Second thing to check is the y value between f of a and f of b. Is the y value between f of a, my God, what this going to happen. Is the y value between f of a and f of b? Second thing I have to check. Well, where is f of a? Where is this? Is it 0? Is this 0? F of a is 0? Is f of b 4? How do I find this and this? Where is f of a? I don't see it. They didn't tell me what it was. Where is it, everybody? I'm looking. Like a lost, lonely puppy. Where'd it go? Where'd it go? How do I find this f of a? Any ideas? Where does this come from? Where do we get that? Haley got it. Yeah. Plug in. F of a. Oops. F of a. F of a is. This is my a, right? This x is my. 0 is my a. This 4 is my b. To find f of a, I need to plug in 0. Yeah, plug in 0 to this equation. It comes from f of a. This is f. I need to plug it in. They don't tell me what f of a is. I need to figure out what my range is. I need to figure out my low and my high. So I got to plug it in. That's okay. F of a is f of 0, which is 0 squared plus 3 times 0 minus 1. And that's negative 1. So I plugged in my a value, got my f of a value. That's my negative 1. Same with f of b. I plug in the 4. I'm going to get 4 squared plus 3 times 4 minus 1. 4 squared, that's 16, plus 0 to 4 is 12, minus 1, that's 28, 27. So I figured out my low and my high. Is my value between these? Is this good? Yeah, right, f of 5, f of x, I'm looking for the value of 5. Is 5 between my low and my high? Yeah, we're good. Check. 5 is between negative 1 and 27. Great. So we checked our interval. We checked for continuity. We checked for betweenness. And so we can state, number 3, we can say, yes, number 3, yes, there, oh God, what's even happening here? There is a C on the interval 0 to 4, because f of x is continuous. I have to state all the things. Is continuous on 0 to 4 and 5 is between negative 1 and 27. Is that all I need to say? Between Yes, there is a c on the interval 0 to 4 because f of x, I got my two statements. F of x is continuous, and 5 is between -1 and 27. Is that good enough? Am I missing anything, everybody? Is there something else I should put in here? Something else I'm missing? Maybe I should add so. There is a c on 0 to 4 where f of c equals 5. I need to put this last thing. I need to put where f of c equals 5. They want to see all three pieces. They want to see the continuity, they want to see the y value check, and I want to see that you say there is a c where f of c is 5. I want to see all three pieces. Let's try another one. Okay? Equation x squared minus 1 over x plus 1 on the interval 0 to 2. Does f of x ever reach the value of 1/2? On the interval 0 to 2, does f of x ever reach the value of 1/2? All right, everybody, same three tests. Same three tests. Oh, what did I say here? Hold on. Did I say plus here? Make this into -1. So I will make that bottom one a -1. X minus 1 on the denominator. All right, three tests. First test. Is it continuous? Continuous on 0 to 2. Are there any discontinuities of this function? Who said no? Lizette? All right, Lizette, Mahia, tell us why. You say no, why? You're so confident. I think you do know why. Tell us what you think. Is it continuous on the interval 0 to 2? Uh-huh. If you plug in 0, like like this 0, you mean like for x? Well, so okay, I mean you're on the right track. You're on the right track. But you're saying if I plug in 0, so you're saying if I do 0 squared minus 1 over 0 minus 1, I'm going to get 0 on the bottom. Doesn't look like 0. That looks like minus 1 over minus 1. That looks like it's fine. No. You're on the right track. You're just not something of the right thing. Haley, you're saying about a horizontal asymptote, and Periso and Jessica, you're saying something about the denominator. Not a horizontal asymptote, Haley, but Jessica, tell us, what about the denominator? What about the denominator? I mentioned it earlier. Yes, I did. Why does it matter? We're checking for continuity. Why does the denominator matter? Is it a jump? What do you mean? I don't think it's a jump discontinuity. Discontinuities really only happen with piecewise functions. Jump discontinuities only really happen with piecewise functions. Parisa, you had an opinion. I said something about division. Yes, I did say that. Where would our asymptote where might we have an asymptote in this equation? So in this equation, we do have a division. Where might we have an asymptote? Unmute yourself, Parisa. No. All right, well, no ideas. Anyone have an idea of where we might have an asymptote? Haley, you said vertical asymptote. Yeah, you said horizontal, but yeah, vertical asymptote. Where might that vertical asymptote be? Do we have a vertical? Looks like we have something on the denominator here. These denominators cause some trouble. Because that thinks it's at -1. So again, you're testing to see what number you plug in would make the bottom into a problem. Jessica thinks it's +1. Those are two different numbers. What would make the bottom into 0? That's the question. The reason the division is a problem is because when you divide by 0, that is where trouble happens, right? I'll say that's where trouble happens. And yeah, in this equation, if you were to plug in x is 1, that would give us a vertical asymptote. Well, actually it's a hole. There we go. It's a hole. It's not a vertical asymptote. It's a problem, though. It's a discontinuity. It's a discontinuity because we are dividing by 0. Discontinuity. Now, 1,000 points for someone if they can tell me why it's a hole and not a vertical asymptote. Why is it a hole? Hey, well, not x exactly. Close. You are simplifying. Yes. Yes. If you plug in 1 to the top, it'll become 0 over 0, right? F of 1 is 0 over 0, and this means it's a hole. It means that you have to simplify, and what you can do. Okay, let me just go through this. What you can do. Remember, is you have x squared minus 1. What you have to do. And this is if you're finding the limit. You have to factor the top. Look at this top part. It's an x squared minus 1. I can do some factoring to this top part. It becomes x plus 1 times x minus 1. This is a difference of squares. You all need to recognize this difference of squares immediately. Oh, x squared minus 1. That's a perfect difference of squares. I can factor that into x squared plus 1, x squared minus 1. I get x minus 1 on the bottom. And that's when my x minus 1s cancel. And I get not just x, very simple, but x plus 1 as my simplified leftover. X plus 1. Remember to simplify. No, we don't need to do any of this. We don't need to do any of this at all. But you need to know that this happens. You need to know that this happens. Factoring, you need to recognize that factoring and know that it breaks up into a perfect square. Difference of squares. Right? You need to know that that happens. You need to know that this is going to cancel and it's going to make a whole discontinuity. You need to know that it is a discontinuity because the bottom equals 0. It doesn't really matter for this purpose what kind it is, but if you know what kind it is, it's important in other questions. Say I wanted you to find the limit as x approaches 1, right? You need to know all these details, right? The full picture of what's happening and connect all the pieces together. So, the question is it continuous on 0 to 2? No, because x equals 1 as a whole, so we're done. We cannot do this problem. Not that we can't do it, but our answer is no, because, or maybe not no, we should say not no, but we should say cannot be determined. Cannot be determined. Because f of x is not continuous on 0 to 2. That would be our answer. Cannot be determined because it's not continuous. We'll see, everybody. That is our situation, right? So you're checking for continuity. If it's not continuous, you say, well, can't be determined because f is not continuous. If I had a different interval, right? If I had a different interval, if I said my interval was, instead of 0 to 2, say my interval was 2 to 5, right? 2 to 5. This is fine because it's continuous on 2 to 5. The only place it's not continuous is at 1. And if that discontinuity, right, if they match up, if the discontinuity matches up with the interval, if it's in the interval, right, if I capture that discontinuity, that's the problem. That's the problem. If the discontinuity is in the interval, that's the problem. If I look at a different section and I have a discontinuity over there, it doesn't matter. If this section is fine, the graph is fine. But if the discontinuity falls in the section of the interval, that's the problem. Okay. So here's what I want you to do, everybody. Take some time. I'd like you to try these questions. Whoa. Try question number 9 right now on a piece of paper in your notes. For problems 9 to 13, determine if the intermediate value theorem would guarantee a C value on the given interval. So here's the function. Here's the interval. Does it guarantee a C value that's equal to 11? Test it out. Do this question right now. Take 5 minutes. Take 2 minutes, I should say. Try this question out. Number 9, try this one right now. Remember, you're testing 3 things. You're testing 2 things, making sure your values are all fitting together. Number 9. Do your tests. All I'm asking for is a yes or no. Does the intermediate value theorem guarantee that value? 1 more minute. All right. Looks like people are giving some answers. So what do we think, everyone? Is there a value on the interval where f of c is equal to 11? On the interval from 0 to 5. I got a few responses so far. Looks like everyone is saying that it's true. So again, we're going to check our 3 things. 1, is it continuous? Continuous? Yes. It's continuous everywhere. I know. Oh, goodness gracious. It's continuous everywhere, I know, because it's a quadratic equation. Yes, continuous. 2, is 11 between f of a and f of b? So I got to plug those in. Plug those in. So I got f of a is 0. 0, let's see, 0 plus 0 minus 1 is negative 1. Great. And then plugging in a 5. 5 squared is 25 plus 5 minus 1 is 30 minus 1 is 29. So 1 to 29, yes. So we're good. We're good. We can guarantee that there is a value c somewhere that equals 11. Great. Number 10. Try number 10, everybody. Take a minute or 2. Solve number 10. Is there a spot where this equation equals 1? Try number 10. So number 9, we said yes. Number 10, what do we think? Does the intermediate value theorem guarantee a value where this function is equal to 1? In the chat, let me know. What do you think? Can we make our statement? Type in the chat, everyone. Does the intermediate value theorem work for this number 10? Got a few answers. People are looking like they're saying no. Yeah, that is correct, right? Is it continuous on the interval? No, because, right, between 0 and 2, we have a discontinuity at x equals 1. And 1 is between 0 to 2. So since our discontinuity is in our interval, that's a problem. So not allowed, right? This one, yes. Number 10 does not work. We're discontinuous. Great. Number 11. Does the intermediate value theorem guarantee a function, a value of 3 on the interval -4 to 1? I'm going to check the two things. Check for continuity and check the range. I want to know, does the function reach the value 3 somewhere on this interval? Does the intermediate value theorem guarantee that? What do you think, folks, in the chat? Type your answers. Saying yes with a question mark, maybe. All right. Let's verify, right? We got to do our checks. First of all, is it continuous? Is this function continuous? Absolute value of x. What does that function look like? Looks like that. Yeah, there's no breaks, no holes, no jumps. Sometimes absolute values can be discontinuous if it was over x, but this is fine. Continuous, yes, no problem. Is the interval okay? Is 3 somewhere between f of a and f of b? F of a is f of -4. My goodness. What is the absolute value of -4, everybody? Absolute value makes it positive, that's 4. Great. F of b is f of 1. Absolute value of 1 is 1. So yeah, our range is from 1 to 4, and 3 is between there, so that's okay. So this one We're good. So we check our variables, we check our intervals, right? Let's see. Number 12. Does the intermediate value theorem guarantee a value of 2 on the 0? Does the intermediate value theorem guarantee a value of 2 on the interval from 0 to 4? Do your 2 checks. This one's a little strange. It's a piecewise function. What does that look like? Piecewise function. Everywhere less than 1, it's this equation. Everywhere greater than 1, it's this equation. Imagine what that would look like. Here's 1. What's that look like? Whenever you see a piecewise function, you have to really be careful checking that they join together. You really want to make sure that the piecewise function is joined together. That is how you check for continuity in a piecewise function. You want to know, do these two, do they match? Do they join together? That's the question. And if they do join together, then they're continuous. If they line up on the same spot. Piecewise functions, you have to check the edges. Piecewise functions, you have to check the edges. And the edge here happens at 1. So our first graph, y equals x, what is that graph equal to at 1? At this value here, my left side, what's that graph look like at 1? Anybody know? How do I find out? Take the value, I plug it in. Remember, that's all you do. When you're looking at piecewise functions, looking at the edges, plug in the number, and that's where the graph is going to go. Y equals x, if I plug in 1, it's going to be at 1. And the graph of y equals x, everyone should know, looks like this. It's a line going straight down diagonal. Slope of 1, right? This is a slope of 1. This is your line. That's the graph to the left. To the right, it's just a 3. What does the graph of y equals 3 look like? Well, that's up here at 3 and continuing at 3 forever. I'm up at 3 for the top half, for the right half of the graph, I'm up at 3. For the bottom half of the graph, I'm down at 1. That is clearly not a continuous function, right? There's a jump there. Piecewise functions, you need to check to see if they match, if their edges match. So this is a no. Jump discontinuity, yeah, jump discontinuity at x equals 1. Does not happen. All right, last one. First, I guess let me just ask you all, is this function continuous? Right, we have a fraction here. So I got a function continuous on this interval. Is the function continuous on the interval? All right, so it says no. Look at the discontinuity. Look at the interval. Look at the discontinuity. Look at the interval. Where does this discontinuity exist? Discontinuity at what number? X equals what value? Yeah, at x equals 1. Where's my range? What's 5 halves? Is 5/2 bigger than 1 or smaller than 1? 1 is over here. 5/2 is what? 2.5, right? So my discontinuity is outside the range. So this one, and if you check, the other numbers work out too. This one's okay as well. Discontinuity, outside range, exactly, outside range. So we're okay. And the other functions, if you plug in 5/2 and plug in a 4, 6 is between those numbers. I don't remember exactly what they are, but it works out. All right, everybody. Well done. Good job. Your homework is on Schoology. Let me show you all. Here on, why am I not seeing it? Where is my Safari web browser? Okay, come on, Zoom. Your homework is down here. It's these questions on Schoology. In the book, page 84, all questions 83 to 60, 83 to 86, 95 to 100, 105 to 107, 115 to 117. Read the questions, try them out. We will go over this. When am I seeing you next? Thursday. All right, everybody? That's it for us. Thank you all. Well done. Fine that you said goodbye. You're free to go. I will see you all next time. Thanks very much.